Today's lesson is Chapter 4, Section 5, Solving Polynomial Equations. After this lesson, you should be able to find the solutions of polynomial equations and the zeros and use the rational root theorem. So to get started, we're going to just kind of build on a familiar concept. So in 4.4, we looked heavily at factoring polynomials. So we're just going to take our factored version of our polynomials and set them equal to 0 to find the zeros. So like I just said, we're going to go ahead and set these equal to 0. And then from there, we're going to factor so we can solve for x. Very similar to what we did with quadratics. We were finding the zeros or finding the roots. So here we're doing that same thing, just with higher degree polynomials. All right, so our very first step, we want to look at what's in common here. And I see in this first problem, I can pull out a 2, and I'm actually going to pull out a -2, so my leading coefficient is positive. That'll just make factoring a lot easier. So I'm going to go ahead and pull out a -2, and then that leaves me with x to the 4th. Then it turns into minus 8x squared. And then this will be plus 16 because I pulled out that -2, all of my signs change. And then this is still equal to 0. So now I look, how can I factor this right here? Well, I have x to the 4th, so I know that can be split up as x squared and x squared. And now I look at 16. What are my factors of 16? Well, I have 16 and 1, 8 and 2, and 4 and 4. And then I look, which of those are going to add or subtract to get me to 8? Well, 4 and 4 is pretty hopeful, right? So I'm going to go ahead and use 4 and 4. And I get 4x squared and 4x squared. Now, what do I need to do with those to get to -8x squared? They both need to be negative. Okay, so this is what we did with factoring. So the only additional step is now this is set equal to 0, so we need to go ahead and set each of these terms equal to 0. And we have 0 equals x squared minus 4, 0 equals x squared minus 4. All right, now I'm going to solve for x, so I'm adding over my 4. And then I take the square root, and I get plus or minus 2 equals x. And notice this is the exact same. So I'm going to do the same exact process. And again, I get plus or minus 2 equals x. So what are my zeros here? Well, I have x equals 2 and -2 from this. And then from here, I get 2 and -2. So I have a repeated 0 at 2 and a repeated 0 at -2. So now, given my zeros, I can make a sketch. There's my x-axis and my y-axis. I'm going to have a repeated 0 at -2 and a repeated 0 at 2. Now, this was a 4th degree polynomial, and my leading coefficient was negative. So 4th degree, it's even, and since it's negative, they're both going to be going in the downward direction. And with a repeated 0 at -2, I'm going to have a turning point at the x-axis. And again, that will happen at +2. And then I can just go ahead and connect these dots here just like that. And that's just a rough sketch, and that is all we need for that. Okay, so now we're working on this second one here. So I look at this and I think, what is the best way to do this? Well, first I need to set it equal to 0. And now I see it has 4 terms, so I'm going to go ahead and go factor by grouping. Right, so I make those 2 groups. Now I look at my first group. I copied this down wrong. What's in common in my first group? What do both terms have? Well, they both have the x squared. If I pull that out, I'm left with x minus 5. Now I look at my second term. What do those both have in common? I know 20 is divisible by 4, so I'm going to pull out that -4. And I'm left with now x. And when I take 20 divided by -4, I get -5. Okay, so now I see these are the same. Perfect, I can group those together and I'm left with 0 equals x squared minus 4 x minus 5. Again, this is all this factoring is a review from 4.4. Okay, so now I set both of these equal to 0 and solve for x. And I add over my 4 here. Take the square root. I get x equals plus or minus 2. Here I get x equals 5. Okay, so this is a good check. I have x equals 2, negative 2, and 5. It was a third degree polynomial, and I ended up with 3 answers, so that's perfect. So I can make a quick sketch here. I have a 0 at negative 2, positive 2, and 5. It was third degree odd, and my leading coefficient here is positive. So I know it's going to end in the positive direction. Whoop. And since it's odd, my end behavior is opposite. And there are no repeated zeros, just it will look something like that. Okay, now for our last one here. We see I have 4 terms, so my gut would be to, again, go to factor by grouping, right? So what's in common with my first group here? Again, this is set equal to 0. I would have 0 equals, I could pull out in x cubed, right? And I'd be left with 2x minus 5. Then I take a look at what's in common in my second. Well, there's nothing in common. There's nothing I can pull out in 10x squared and 9. The only thing would be a 1, right? And that's not going to do me any good. So now I'm stuck. I don't know what to do. I have 4 terms. It doesn't factor by grouping. What do I do? Well, this is where the thing called a rational root theorem comes into play. So what the rational root theorem is it gives us possible solutions or possible zeros. So how do we find those? Here's a list. This is the same equation we were just looking at. And here are our possible solutions, all right? And they got this using the rational root theorem. So if we take a look at what that means, is if we're given a polynomial, the possible solutions are the factors of the constant term over the factor of that leading coefficient. So first and foremost, we have to make sure our polynomial is written in standard form, as this is. And then we take a look at the factors of our constant term, right, which in this case would be the 9. So what are the factors of 9? Well, 9 and 1, 3 and 3, right? And now we take a look at what are the factors of my leading coefficient. Well, they are 2 and 1, right? Those are the only factors of 2. So the possible solutions are all of the combinations of the factors of my constant term over the factors of my leading coefficients. So as you can see, they took 9 over 1, 9 over 2, 3 over 1, 3 over 2, 1 over 1, and 1 over 2. And that's how they got this list. And then all of those are plus and minus as well. So in this list, we have 2, 4, 6, 8, 10, 12 different options for what a 0 could be. All right, so the rational root only gives us possible solutions. But now that we have those possible solutions, we have to test those to see which of those are actual roots or solutions or zeros to the given polynomial. So I know that was a lot. Let's go through and do an example. Okay, so use the rational root theorem to find all real solutions. So we know we need to take the factors of our constant term and over the factors of our leading coefficient. Well, the factors of our constant term here are, we have 20 times 1 give us 20, right? 10 and 2. And 5 and 4, correct? Those are all of our constant term, or all of the factors of our constant term. And those are going to be over the factors of our leading coefficient. Well, here our leading coefficient is just 1. So our options, our possible solutions are, now remember it's the positive and the negative of that. So it's 20 over 1, 1 over 1, 10 over 1, and these should all be plus or minus. 2 over 1, 5 over 1, and 4 over 1 plus or minus. All right, so here we have 2, 4, 6, 8, 10, 12 different options again. And the reason I counted by 2s was because that plus or minus, right? So that's going to be positive 20 as well as negative 20 are all of my options. So now we have to try all of these to determine our actual solution. And to do that, we're going to use synthetic division. So I'm going to set this synthetic division up. Remember, we're using our coefficients. So 1, negative 8, 11, and 20. And what are we going to be dividing by? Well, our possible solutions. And this is just, again, you pick one and try it. I like to start with 1, and if that doesn't work, then I go to negative 1. So I'm going to start with 1 and see what happens here. We will know it is a root if our remainder is 0. Okay, so we need our remainder to be 0. So I bring down my 1. I get 1 times 1. It's just 1. And remember, now I'm adding. So that gives me a negative 7. Negative 7 times 1 is negative 7. And I add those to get 4. 4 times 1 is 4. I add to get 24. Now we see my remainder is not equal to 0. Okay, so this is x equals 1 is not a solution. All right, so now I'm going to go ahead and try negative 1. We can cross positive 1 off of our list. Again, 1, negative 8, 11, and 20. 1 times negative 1 gives me negative 1. When I add, I get negative 9. Negative 9 times negative 1 is positive 9. I add to get 20. 20 times negative 1 gives me negative 20. I add and I get 0. Here my remainder is 0, so x equals 1 or x equals negative 1 is a solution. Which means x plus 1 is a factor. All right, so if x plus 1 is a factor, this is what I have left, right? So if you think back to synthetic division, when I get a remainder 0, then I use my whatever's left, right? That's my new answer. So I have x plus 1. Now we started with x cubed. So my answer is going to be x squared. So I have x squared minus 9x plus 20. All right, so now I got one factor out. Now I know how to factor this, right? It's an x squared. I can go ahead, split that up as x times x. And for 20, I would use 5 and 4, right? Because that's the closest together, the most broken down. That's just where my instincts are. And I look, don't forget we're also multiplying by x plus 1. What are my signs here? Well, I have 5x and 4x. Anyway, with 5x and 4x, I can get to negative 9x. Of course, if I subtract both of those, okay, so now I need to solve this, right? This should be set equal to 0. That was our whole initiative. So I need to find my zeros. I go ahead, set all of these terms equal to 0, and solve for x. So I get x equals 4, x equals 5, and x equals negative 1 as the solutions to this, or the roots to this polynomial function. And if we go back and look, it was a cubed function, right? X cubed, third degree polynomial, and we ended up with 3 answers. All right, so now we have multiple ways we can solve polynomials. We can use the rational root theorem, if we can factor, or we can factor by grouping, right? So I want you to pause the video, give each of these 3 a try, and then come back and check your answers. So with the very first one, I see there's 4 terms, so my gut first would to be factor by grouping. So I would group the first 2 terms and the last 2 terms, right? I would have, look what's in common in that very first set. Well, x squared. I can take out an x squared, and I'm left with x minus 5. Now I look at what's in common in that second group. Well, I know 45 is divisible by 9, so I'm going to go ahead and pull out that negative 9, and I'm left with x minus 5. Minus 5 because I pulled out a negative 9. These are the same, so I can group those. And now I set both of these equal to 0. And I get, add over my 9, take the square root, x equals plus or minus 3, and x equals 5. Right? Recognize it was a cubic function, so I have 3 answers. Okay, on the second one, I see there's 3 terms, so I'm going to look what's in common with all of these 3. Well, I see a q squared. That's what pops out at me first, but and then I look, is there anything else in common? No. So I have 0 equals q squared. Once I pull that out, I'm left with 2q squared plus 5q minus 18. Now I have a quadratic here, so I know how to factor quadratics. Split this 2q squared up into 2q times q, and I look at what are the factors of 18. Well, I got 18 and 1, 9 and 2, or 6 and 3. And I usually start with the most broken down, so I'm going to go ahead and do that. 6 and 3. I get 6q and 6q. Anyway, with 6q and 6q, I can get 5q. No, so I would switch those. I have 3q and 12q. Anyway, with 3 and 12, I can get to 5. No. So then I can cross 6 and 3 off my list, and I move up to 9 and 2. And I get 9q and 4q. Anyway, with 9 and 4, I can get 5. Yep. If I need positive 5, so I'm going to add 9 and subtract that 4. Okay, now I have it factored, so I need to go ahead and set all of my terms equal to 0. So I have q squared equals 0. I have 2q plus 9 equals 0. I have q minus 2 equals 0. Here I get q equals 0, and that's repeated twice because that's squared. Here I get 2q equals -9, then I divide by 2, q equals -9/2, and here I get q equals 2. So again, it's a 4th degree, and I have 4 answers, 1, 2, 3, 4. Perfect. Now lastly, I see 4. My gut would be to go towards factor by grouping. I could pull out an x squared. I'd be left with x plus 1. But I see here 17x and 15. Well, 17's prime, so there's nothing I can pull out of there. So after I check that, I have to resort to the rational root theorem. Okay, so I look at 15. What are my factors of 15? Well, 15 and 1. And 5 and 3. And I look at what's my leading coefficient? Well, it's 1, so I only have one option there. So what are my possible roots? They are plus or minus 15 over 1, plus or minus 1 over 1, plus or minus 5 over 1, and plus or minus 3 over 1. Okay, so now I go ahead and I use synthetic division to find my first root. And again, like I said, I always start with 1. It just seems to be kind of lucky most of the time. So I'm going to go ahead, use synthetic division here. My coefficients are 1, 1, -17, and 15. So I'm going to start with x equals 1. 1 times 1 is 1. I add to get 2. 2 times 1 was 2. I add to get -15. -15 times 1 is -15. I add those. I get a remainder of 0. So I know that x equals 1 is a solution, which means x minus 1 is a factor. And then I'm left with x squared plus 2x minus 15. Now I have a quadratic in this second part, so I can go ahead and factor that. I know that factors as x and x, and then I look at 15 again. 15 and 1 or 5 and 3. Like I said, I like to break it down as much as I can. Now anyway, with 5x and 3x, I can get to 2x. Yes, if I have 5x minus 3x gives me 2x. So I'm going to have a positive 5 and minus 3. All right, now these, remember, are set equal to 0. So I'm going to go ahead and set each term equal to 0. And solve for x. So I get x equals 1, x equals -5, and x equals 3 as the solutions. Okay, so now we have an application problem. Archaeologists discovered a huge hydraulic concrete block that at the ruins of Caesarea with a volume of 945 cubic meters. The block is x meters high by 12x minus 15 meters long by 12x minus 21 meters wide. So I'm just going to go ahead and sketch this out. It said x meters high by 12x minus 15 meters long and 12x minus 21 meters wide. So that's our box they found. Now, what are the dimensions of the block? So they're asking us for the dimensions. Now, if we think back to geometry, this is a cubic or a block, right? So a rectangular prism, that's called. And the volume is what we're looking for. They give us volume, and volume is our length times width times height, right? Thinking back to geometry. So they give us the volume, which is 945. Now the length, the width, and the height are x times 12x minus 15 times 12x minus 21. And we need to solve for x. So I'm going to go ahead and multiply these out. So I get 945 equals 12x squared minus 15x multiplied by 12x minus 21. So how I got this, I multiplied that x. Now I'm going to FOIL here. And I get 144 x cubed minus 252x squared. Distribute my 15 minus 180x squared plus 315x. Now remember, this is all equal to 945. Well, if I want to solve for x, I want to set this equal to 0. So I'm going to set this equal to 0 and simplify in the same step here. So if I subtract over my 945, I have 0 equals 144x cubed minus 250. Oh, I'm sorry. This should have been 180x squared. And then my 252x squared minus 180x squared gives me negative 432x squared plus 315x. And then I have my minus 945. Okay, so now I see 4 terms, so my gut would be factor by grouping. And since we're working with big numbers, things we're not familiar with, I know my x's can come out. I'd pull that out first. I see that in common. But I'm going to go ahead and check and see if 432 is divisible by 144, because if so, that would be very helpful. So I take 432 divided by 144, and I get 3. So that means I can pull out a 144. And I'd be left with just my x minus, we said 432 divided by 144 was 3. All right, so I'm going to go ahead and check the same thing. Is 945 divisible by 315? And in fact, it is. So I can pull out a 315. And I'm left with x, and then 945 divided by 315 is 3. Well, that worked out nicely because now these match, so we can combine those. And we get 144x squared plus 315 multiplied by x minus 3. Right, so now I set each of those equal to 0, and I solve for x. This should be x minus. Okay, so now I'm going to subtract over my 315. I get negative 315 equals 144x squared. I divide by 144. I get negative 315 divided by 144 equals x squared. To solve for x, I need to take the square root. And remember, when we're taking the square root of a negative, we get plus or minus I, right? Square root of 315 over 144. Now I can definitely reduce this, but let's just take a look before we go any further. Does it make sense if we're looking at length measurements for that to be imaginary? No, it doesn't, right? So we look over here, we have x equals 3. We got 3 answers because it was a cubic function, degree 3, but 2 of our answers don't make sense because 2 of our answers are imaginary numbers. So we're going to go ahead and disregard those because imaginary lengths just isn't doesn't make sense with the context of our problem. So we get x equals 3. Perfect. That's exactly what we needed to do. But now they're looking for the dimensions. So we have one dimension. We have the height, which was 3. But we need to solve for our length and our width. So we're just simply going to plug in 3 for x. And then we take 12 times 3 minus 15 to get 21. And then we take 12 times 3 minus 21 to get 15. So my dimensions are 3 by 21 by 15. Okay, and that's all we have for today's lesson. As always, complete the homework and complete the formative to go along with 4.5 day 1. And as always, if you have any questions, please do not hesitate to reach out to us. We'd be happy to answer any questions we can.